Hi, I'm David Snopek from Snopek Games, and this is part 2 in a video course about using the Git version control system with a game project that uses the Godot game engine. So, a quick review of what we learned in part 1. We talked about what a version control system is. We learned some terminology, including repository, revision commit, branch, merge, push, pull. I explained why I think you should always use version control with any Godot game project, whether you're solo or on a team, whether it's a small prototype like a game jam project or a serious project. I think you should always use a version control system. If you want to know why, watch the previous episode, and why we are going to use Git in particular as opposed to other version control systems. So if any of that interests you, go check out the first video. But what are we going to talk about in this video? Well, we're going to be installing Git for Windows. And we're going to be doing Windows because that's what most people use. I think that would benefit the most people. I don't personally use Windows on a regular basis. I run Linux. So we're actually going to be using Windows in a VM, a virtual machine, for the presentation. But I figure if you run Linux like I do, you probably already know how to install Git. It's the same way that you install everything. You just use your package manager, install Git. It'll work. If you use macOS, I am really sorry. I just don't know that much about macOS. And I don't have a working macOS VM, so I can't even figure it out. But I did search briefly on YouTube. I just searched for install Git on macOS, and it turns up a whole bunch of videos. Hopefully one of them is actually good, because if you can figure out how to install Git, get it installed, you can then return to this video and follow along with us for the rest of it. We are going to be covering both Git from the command line and from the graphical user interface. And I'm going to talk a little bit more about why on the next slide. We're going to be creating a Git repository for your Godot game project. We're going to be adding a .gitignore file, which is a special configuration file for Git, specifically for Godot game projects. We're going to be adding some files and making commits to your repository, and we're going to be looking at your vision history. So, why are we going to be covering both command line and GUI? I could definitely... Oh, sorry. I wanted to explain that GUI is GUI, stands for Graphical User Interface. I just wanted to throw that in there because I remember the first time I ever heard someone say GUI, I was so confused. I was familiar with the abbreviation GUI from books and articles and stuff, but I'd never heard anyone say it out loud, and it just threw me for like the whole conversation that I was trying to have with someone about this. Anyway, so GUI, GUI, Graphical User Interface. So I can imagine some objections from you guys. Maybe you don't do command line. Maybe you're thinking, I'm an artist, I'm a level designer, I'm not a programmer. Command line is crazy and weird. Or maybe you're coming from the other side and you're a developer or programmer and you think the graphical user interface is bad or confusing or inefficient or something. And I hear you. Like, both of those make perfect sense to me. However, I think it's valuable to do both. Why the command line? Because it is the native way to use Git. If you're going to have any problems or questions or need additional help, that help you're going to find is probably going to reference Git commands. And so having some familiarity with how Git is used on the command line is going to help you in the long run for figuring out problems or learning new things about it. It's cross-platform. The command line instructions that we're doing today will work the same on Windows, Linux, and macOS. And it's simpler, which might not make a lot of sense to people who don't normally use the command line, but it's kind of like if you only need 4 commands, and those are all the commands that you know, those are like the only commands that exist, right? Whereas in like a GUI application, you'll open a drop-down menu, and there'll be like all 40 things in there, and like so you have to see all 40 things that are possible, and then you go to run one of those commands, and it's going to, open up a dialogue with all of the options for that command represented. Maybe there's like 10 options, but you really only personally need to care about one or none of them, right? But, the GUI is going to hit you with all of them laid out with checkboxes and inputs and all that stuff. Whereas the command line, like I said, if you only know the commands that you need to use and only know the options for them that are important to you, that's kind of like all that exists. Like, you don't need to even know that the other stuff is there. And so in that way, it's kind of simpler. And also, I'm going to share a cheat sheet with you. In the description with this video, I'm going to link to a document that has all of the commands that we are going to run in this course. So you can see them, you can look back to them, and you can copy and paste them. Why do the graphical user interface? Well, because for most people, the command line is totally foreign and crazy, and I 100% expect that the people who watch this video, they're going to see the command line stuff, be like, oh, that's interesting, and I'm glad that they, saw it. But on a day-to-day basis, they're going to actually be using the graphical user interface because that is what is most natural to most people. And that's fine, because who cares? Like, the tool and the value that you get out of the tool are what matters, not, what interface you use for it. And it's also easier to remember than memorizing commands. So this is like the sort of flip side of the simpler. Like, yes, you click that drop-down menu, and now you have to see all 40 commands, but you don't have to remember what they are. You can sort of browse through there and be like, oh, yeah, that's the one I wanted. So that is why we are doing both command line and GUI. So let's get started. I will switch over to my Windows 10 VM over here. And the first thing we're going to do is open up our trusty web browser and browse over to git4windows.org. I will have a link for that in the description as well. Go there. There's this big blue download button at the top. Click that. Press run. And yes, I would like to allow it to make changes to my device. This is going to open like a pretty standard Windows installer. There's going to be a lot of questions, but I'm going to assume that if you are watching this video, you don't understand or don't care yet about all of the different nuances to these questions. So for the most part, we're just going to click all of the defaults. We're just going to keep hitting next, except for one question, which we are going to stop and discuss because it is very important. So the license, next. Where is it going to install? Next. It already exists because I installed it earlier. Components, next. Name, next. All right. On this step, choosing the default editor used by Git. Which editor would you like Git to use? The default is Vim. And unless you already know Vim, you already use Vim on a regular basis, you do not want Vim. It is confusing and weird and totally unapproachable if you don't already know how to use it. I feel terrible saying that because Vim is actually my preferred text editor. I use it every day, but I'm an ancient dinosaur who learned how to use Vim over 20 years ago. It's a strange old school Unix thing. Don't pick it. Okay, there's a whole bunch of other options in here. The one I'm going to recommend for most people is Notepad++. That is an open source, free, general purpose text editor. Really simple to download. Just Google it, download it, take just a moment. And it's like a normal modern application. You've never used it before. You'll be able to go in there and change text and click save and whatever. It's good. Also, there's a whole bunch of other options. If any of these editors are your like normal day-to-day editor and you have them installed on your machine, feel free to pick them. That's fine. If there's another editor that you're really, really attached to that isn't on this list, you can always go down to this last option and pick select other editor and just browse to where it is on your machine. But we are going to pick Notepad++ for this presentation. And for the rest of these, you can just click next. None of the rest of these questions really are important. The defaults are probably fine for you. All right, it is finished. We don't need to view the release notes. So Git is now installed. What does that actually get us? It gets us two applications. The first is git bash. This is actually the Git command line. So here is where we would type commands to Git. And the other one is git GUI. And this is the graphical user interface for Git. So we are going to start using the command line. We're going to go through and learn a bunch of stuff with the command line, and then we're going to come back around and do all the same stuff over again with the Git GUI, except for this first thing, which we are actually going to do only on the command line because I couldn't figure out how to do it on the Git GUI. But it's something you only ever have to do once for your computer, and then you never have to do it again. So it's not that big of a deal. We have to tell Git who we are. We have to give Git our identity. And to do that, we're going to type 2 Git commands. They are probably the scariest looking commands that we are going to have in this course. But like I said, there is the cheat sheet document. You can just copy and paste them and change the relevant parts. And also, like I said, we're never going to have to run these commands again. So the first one is we're going to tell Git our name. We're going to do git space config space -- global space user dot name space, and then you will put your real name or whatever alias you want to use to the world in parentheses here. Or not parentheses, no. Quotation marks, in quotations. And so I'll put my name here, David Snopek, and then hit enter. It will give us no feedback. It will just give us another line to enter our next command on. Generally speaking, on the command line, no feedback means success. If there is an error, it will give you a message about the error. And sometimes success will also give you messages and stuff too. But if you see nothing, don't worry, it worked, right? To the next command, we're going to tell Git our email address. So git space config space -- global user dot email. And again, remember, you can copy and paste these from my document. And in quotations here, we are going to type our email address. However, I want to give you one note before that. Your name and your email are going to be included in the metadata with every commit you make. And if you publish your repo publicly so that anyone on the internet can access your repo, that means anyone on the internet will be able to get your email address. And maybe you don't want to do that for privacy or spam reasons. So I just wanted to give you that warning. If you only publish if you only make a private repo and only share it with your teammates, only your teammates will have access to your email address, and then it's probably fine. But I just wanted to give you that warning. For me personally, I long ago started using my real personal email address for Git, and so it's already been exposed to the internet forever. So I'll just put in my actual real email address there and hit enter. So now Git knows our name and our email. It will put that as the author of all of the commits that we make. And you don't ever have to do that again, at least on this machine. When you reinstall or work on a different machine, you'll have to tell Git who you are again. Otherwise, Git will give an error every time you try to run any other commands that it doesn't know who you are, so it can't make the commit. All right, so I'm going to close that window, and we're going to create a Git repository. But to do that, we need a Godot game project. So I made a really simple project. It's just a 2D one scene called main with a root node of node2D, a sprite, which is the icon.png that Godot puts in every new project, with a simple script attached to the main node here, which has a process function that makes a vector out of the arrow keys using the UI input actions. In a real game, I don't recommend using the UI input actions for your player control, but this is not a real game. This was just put together for expediency to demonstrate Git. Normalizes that vector, and it adds it to the sprite position, which again is not how you would probably, or almost definitely, not move your player character in a real game, but this isn't a real game. So let's just run it so you can see what this does. I'm pressing the arrow keys, it's moving this icon around. Simple. So this project is actually located in this directory, git test1. You can see, there's the main.tscn, the main.gd that we were just looking at in the editor. So to create our repository, we first need to open git bash here, which to do that, I'm going to click inside of this directory window and select this git bash here. And that opens this command line window again. except it is in the directory that I right-clicked in. So we're going to run the command to create the Git repository, which is git space init, I-N-I-T, and hit enter. And it tells us initialized empty Git repository in path to project.git. So that actually creates a .git directory here. And this is where the local copy of your repository exists. There is like some configuration file in here, and you can make some hooks and do some advanced stuff, which we're not going to do today. Maybe not in this course entirely. But I just wanted to point out that this is where the repository lives, so that you know where it is, right? So you aren't imagining that this Git repository lives in some magical other place on your hard drive, such that you could like delete your project directory and then like check it back out from the repository, because this is your local copy of the repository in this directory. In a future part, we're going to be pushing your local repository to GitLab, so then you'll have a copy at GitLab, and then you could like delete your directory and then pull, the remote copy of your repository back down. But I just want you to know that this is where your repository lives, so you know to be careful with it. All right, so next we're going to learn the command git space status. We're going to be running this command a lot. It tells us different information about the current state of our working directory. It tells us that we are on branch master. All newly created Git repositories will start with a default branch called master. It has no commits yet. And it tells us about a bunch of untracked files. So these are files that aren't in the repository. And it has this git.ignore file that I was planning to create together with you. I must have forgot to remove it after I was practicing this presentation. Sorry about that. I've deleted it. Now we will run git status, and that git.ignore file is not there, but now there's this .import/ file there. All right, so what we want to do is add the files in our project to be staged for commit and then commit them. So to stage a file for commit, we run the command git space add, and then we give the name of the file that we want to stage for commit. So how about we do the main.gd file? And now we'll run git status again, and you will see that there's this new section, changes to be committed, with new file main.gd, with all of the rest of the files still as untracked files. Now we could do git add and type each of the names of all of the files in the project to get them all staged for commit. However, there is a way to tell Git to stage all of the files in the current directory and child directories. The problem is there is one thing in here that we don't want to be in our repo. We don't ever want it to be in our repo. It's this .import directory. So you may already know that Godot needs to import some resources into a different format in order to actually use them in the game. For example, our icon.png needs to be imported into a different format in order to actually be sent to the GPU to be rendered in the game. Godot does that automatically. You just put the file in your Godot directory, and Godot will give its little importing dialog, and it will create the imported version of the file over here in this .import directory. So this directory is important for actually running your game, but we don't want it in our repository because all of these imported files are essentially just duplicates of files that we already have. Like the icon.png is now being duplicated in its imported format in here. And that's just going to take up space in the repository. And making sure to not make your repository too big is a concern we're going to talk about more in a future episode. But just to say shortly, like, we don't want to have extra crap in our repository. We want to have just the source files, like the icon.png. So we can tell Git to always ignore this directory and all of its files by creating a .gitignore file. So I'm going to create a new file named .gitignore with no extension or anything. and I'm going to edit this with Notepad++. And the way this file works is each line has a pattern that we want Git to ignore. So the pattern we're going to put in is /.import/. And that tells Git that we want to ignore a directory, that's what the slash at the end tells us, named .import, and only a directory named this that exists in the same directory as the .gitignore file, right? That's what that leading slash is. If we took this away, it would actually ignore all folders, all directories named .import in any child directories of this directory. But we just want this one specific directory at the top level here to be ignored. So that's what we put there. I also frequently, pretty much always, I think always, also put a build directory to ignore here, because I always export my projects into a directory called build inside of my project. Not everyone does that. Some people put them in other places completely, so it doesn't matter. But that's where I put mine. So I also put this /build here in all of my projects. And if there's any other files that you want to ignore, you could also put them here. A common one is doing like blend star, because like if you're doing a 3D project, Blender creates like blend 1, blend 2, like every time you save. I'm a Vim user, so it always creates these .swap files. You could put star.swap, and that's any file name that ends in .swap anywhere in the project. Git will just automatically ignore. But just as a sort of baseline, we're going to put this import and build here. Save that. Go back to the Git command line. We're going to run git status again. And you will notice there is now the .gitignore file is present, and the .import directory is no longer present. So now we can run git add space dot, just a single period. And this is going to add all of the files in the current directory and child directories except for the files that match the patterns in the .gitignore file. So I'm going to hit enter. You'll see these warnings. elif will be replaced by clr elif. You could ignore these. To give like a really short explanation of what that's about, Windows text files use a different line ending character than other operating systems, and so Git will like automatically convert between like the normal line endings and the Windows line endings for you, and it's just warning you that that's going to happen. But that doesn't matter for us. Godot will run just fine using the normal line endings or the Windows line endings, so you could just ignore that every time it comes up, and it's going to come up a bunch. So we did git add. Now we're going to do git status, and you will see under the changes to be committed section, we now have all of the files in our project that we want to be committed. So let's create our first commit. We're going to do git space commit. And now it's going to open up Notepad++ for us to enter the commit message. This is where it's important which text editor you selected during installation. If you had selected Vim, the default, you would now be presented with a Vim window, and you're probably not able to figure out how to enter any text or even leave it. I guess pro tip, if you want to leave that window, press :Q and hit enter and you'll get out of there. But we chose an editor that's easy to use, Notepad++, which is showing us this sort of template that we are going to type our commit message into. You'll notice all these lines here that it added for us. All of these lines, starting with the pound here, are going to be ignored. They're not going to be actually included in the commit message, similar to comments in a GDScript file. And they're just here to give us a little bit of information about what we're about to commit, just to give you kind of like a last chance to notice if you made a mistake. Like if there's a file in here that says new file is going to be committed, and you're like, oh no, I don't actually want to commit that. You can then exit out of here, which will abort the commit process, remove that file from the list of files to be staged, and then commit again. So above here, we're going to type our actual commit message, which is going to just be initial commit. And we hit save, close Notepad++. We'll get a little bit of feedback here from Git saying it made a commit on the master branch. It's the root commit, which means it's the first commit in that branch. Here's our commit message, or the first line of it. If you typed a lot, it just gives you the first line there. 7 files were changed, 89 insertions. Insertions means lines added. If we had removed any lines, we'd also get a number of deleted lines. And then here it tells us about the new files. So that commit was successful. A little bit of stats about it. We can type git log, L-O-G, and this will give us a list of all of the commits in our current branch. So you'll see a little bit of metadata at the top here, commit, and this long bit of gobbledygook. This is actually the commit ID. This is what Git uses to uniquely identify this commit within the repository. You may remember from the last video, in my diagrams, I was showing the commits as being numbered, like 1, 2, 3, 4. There was revision 1, revision 2, revision 3. Some version control systems actually do it that way with an incrementing number. Bazaar, Subversion, they both do it that way. Git doesn't. It does it a kind of more confusing way by assigning these long hashes as the commit IDs. We're going to talk more about these hashes in the next video. For this one, you just need to know that this is the ID for the commit. It gives the author with my name and email, like we talked about before, and when the commit was created, and our commit message. So let's make some more changes, make some more commits. Let's go back to the Godot editor here. Let's add a speed variable. Say speed equals 200. And that's going to be 200 pixels per second. We'll make it per second by multiplying it by the delta. Save that. Hit play. You'll see that the icon moves a little bit faster than it did before. So our change is working. Always good to check that. And now if we go back to our git bash window, we can type git space diff. And this is a command that's going to show us the changes that were made to the files in our working directory since the last commit. So I hit enter, and I'm going to just page down to the bottom here. It will show the lines that were added with a little plus sign and in green. So you can see these two lines were added, the var speed 200 and this blank line. And it's going to show lines that were removed with a little minus sign in front and in red. So this line here was removed and replaced with this new line here. So this is how Git shows you the differences. And I'm going to press Q to get out of this listing application. And then we're going to type git status. And we'll also see here that changes not yet staged for commit is this modified main.gd. So we learned a moment ago that to stage things for commit, we do git add. We could type the name for the file, or we could just type dot, which will just add everything in this directory and the child directories, except for the things that were in the .gitignore file. But I want to teach you a new thing really quickly, which is we can also do git commit space -a. And what this does is rather than staging the files that have changed for commit and then committing them, this will automatically stage everything in your project that has changed that Git already knows about. So it won't stage new files. It'll just ignore new files that have never been added to Git. But any files that are already in Git, this will automatically stage and commit them. So this can save you some time, conceivably, if like you have a whole bunch of files in there that you don't want to stage for commit but aren't git ignored, and you also don't want to do git add to each individual one, you can just do git commit -a. So let's do that. We'll hit enter. Notepad++ again comes up with this little bit of information about the commit, and we're going to type the commit message above that. We're going to say added speed. I will save it and close Notepad++. It again gives us this new line warning that we're going to just ignore every time we see it, and a little bit of information about our commit. One file was changed, there were 3 insertions, 1 deletion, and now if we run the git space log command again, it will show us our 2 commits. We'll have our initial commit here with its metadata and message, and our new commit with its metadata and commit message. So let's make one more commit. We're going to add a new file to our project. We are going to add a background for our icon to move around on. If we go over to over to Godot, we'll see it importing this new image. It's actually going to take a little bit because it is a very big image. All right, I'll switch over to the 2D view and drag this into our scene as a sprite and rearrange our node hierarchy here. Save and play. And now our icon is a nice grassy lawn to run around on. So going back to our git bash window, we're going to do git status. We can see that there is this file changed but not staged for commit, and there are these two untracked files. So we can't do git commit -a because, like I mentioned before, that wouldn't commit any new files. This would just commit the changes that we made to main.tscn and not get these. So we have to do like we did originally with the git space add and then dot. And that will commit everything in this directory and child directories except for the things in the git.ignore or .gitignore. And we'll do git status, and we'll see that all of these changes are staged for commit. So we will commit them, type a commit message, added background, save it, close it, type git log, and now you will see we have 3 commits for each of those sets of changes that we made. There is one more quick thing that I want to show you about staging commits, more as a warning, so that you don't encounter this problem when you're actually using Git later, and that's that when you stage something for commit, what will actually be committed is the file as it was when you staged it. So if you make some changes, stage a file for commit, and then make some more changes to that file, and then commit, it will not commit your latest changes, it will just commit the changes to that file as of the time when it was staged. I hope that makes sense. Maybe to make it clearer, let's actually do it. We'll go over to our main.gd. We are going to add a random comment, blah. Let's go back to our git bash. We'll see git diff. You can see we added this blah line, and we are going to stage the main.gd for commit. So if we look at git status, main.gd is on the changes to be committed. Now if we go back here and add a further change, a commit with another change, and we jump back to our git bash and we do git status, we'll see that main.gd is listed both under changes to be committed, because we staged it earlier with that first change, but then also under changes not staged for commit, which is just about that second change. And if we do git commit here, it's going to commit just the first change we made. So we'll say added blah, and save it and close it. And now if we do git status, you'll see that the stage for commit is gone, but the main.gd is still modified. And if we say git diff, we'll see that this another change comment is in the file, but still hasn't been committed. So just a warning, if you stage something and then make further changes, you'll either need to stage it again. You can stage it again to stage now the new copy of it. That's just with git add again. Or if you do git commit space -a, even if you had previously staged the file, that will go back through and automatically stage everything that has changed. So that is why, another reason why that command, the git commit -a, is pretty useful. So I hope that gives you a kind of an idea of a handful of commands and the sort of day-to-day usage for how to use Git with a Godot project from the command line. We are now going to go back and redo all of those steps using the Git GUI. So I'm just going to go off the video for a moment and reset everything. So to start, here is the folder with my Godot game project. I'm going to right-click in it and go down to Git GUI here. That'll open up the Git GUI with this as kind of its root directory. We're going to click the first link here, which is create new repository. and then we will browse to find the directory with our project, which, because we did git GUI here, it actually will start right from that directory. So we can just hit select folder and click create. And you'll see this again creates the .git directory within our project, which is the empty Git repository, and switches to this kind of dashboard view, which has a bunch of different frames and some kind of action buttons here. Now, in this first frame, you have unstaged changes. So this is one of the things we saw when we were running git status, which is the kind of like untracked files or files that have changed that aren't staged yet. And you can see that it has all of our normal project files here, but also these files under .import, which we want it to ignore. And we make it do that in the same way that we did in the command line part. We're going to create a new text file called .gitignore. And we are going to open this up with Notepad++, and we're going to create it with the same contents as we did last time, /.import /build/, and we're going to save that, close it, and when we go back to the Git GUI, we have to hit this rescan button, which will recheck everything in the working directory, and it updates this unstaged files. You see those files that were in the .import directory are now gone, and this .gitignore is now here. So we need to stage these unstaged changes for commit. So to do that, we're going to select all of these. I'm going to click the top one, hold down the Shift key, and click the bottom one, which will select them all. And then I will click this Stage Changed button. Stage 7 untracked files? Yes, please. And then it gives us, the same warning we've been ignoring forever about the line endings. We'll click the Continue button just to skip past this. And now you'll see all of the files that we had selected are now in this Stage Changes. We'll commit frame. And then to actually commit them, we'll go over to this text box, which is where we type our commit message. We'll type initial commit dot, and we will press commit. Actually, before I do that, I just want to point out that this frame up here is showing us basically the same as what the git diff command did when we were doing it from the command line. This shows us the differences that we are actually committing with that same plus sign for added files. Since these are all new, because there's no commits in this repo yet, it's saying plus for every single line in every single file. But I just want to point that out real quick. So now that we have our commit message here, our file stage for change, we just click commit, and it's committed. So to see your history, you click repository and go down to visualize masters history. And this opens up this cool app, GitK. In my mind, I actually say it as GitTK because TK is a graphical user interface toolkit that this is actually built with, but whatever. It's actually spelled just Git and then the letter K. And it's a really great tool for visualizing complex histories. I use it a lot, even though I use the command line primarily for Git. But when I have a really complicated history to look at, I just type Git K and it opens up this app. So it's useful for everyone, not just users of the Git GUI. Anyway, you can see that this history is not complex. It is very simple. We have the master branch, which just contains one commit, the initial commit. Here's the author. Here's the date, time that it was created. Here you see kind of the same metadata we were looking at before in the git log command and the git commit message and the diffs that make it up. So let's go through the same changes we did earlier and make those same commits. We'll go back to the Godot editor, and we will add that same speed variable, 200 pixels per second, integrated into our math here. We'll save, press play. We'll see that this goes a little bit faster around with the new speed. And now let's go back to the Git GUI. So nothing has changed. That's because we have to click the rescan button, which now shows that there is one file with unstaged changes. That is the main.gd. If we click on it, if there are multiple files here, you have to pick which one you want to click on here. It just kind of automatically selected it. But the one that's selected will show the diff over here, which is the same as we saw before in the command line section with the plus showing these 2 new lines added, and this minus and red showing the line that was removed and the line that then replaced it. So again, we'll click it, click Stage Changed. This warning about line endings, we'll hit Continue. Now main.gd is staged for commit. We'll type our commit message, added speed, and click Commit. And it's committed. We go back to our Visualize Master's History, and we can now see that there are 2 commits. So for completeness, let's just do the same change again that we did in the last section and add this background. I'm going to drag the background over here, I'll say copy here, and then we'll go over to the Godot editor where it's going to again import this image. Switch over to the 2D view, drag this onto our scene, rearrange our node hierarchy so the sprite is on top, save, play, there we go, close that out, go back to the Git GUI, we'll hit rescan, we'll now see that the background.jpg, background.jpg.import, and main.tscn are unstaged changes. We can see even in the main.tscn, these are the actual lines that have been added and removed inside of that file. The scene files are just simple line-based text files like really all of the configuration files in Godot. So we'll again select all of these. I'm going to click the top one, hold the Shift key, click the bottom one, click the Stage Changed, Stage 2 untracked files, yes. Again, we don't care about this line endings thing. Here the files are staged. We'll type our commit, added background, click commit, and it's done. Let's go visualize our history, and we now have these 3 different commits in our master branch's history. So, there we go, is really all that I wanted to show to you today. If you have any questions, if there's anything I missed, if there's anything unclear, if there's anything in particular you want to see in the next part, please let me know in the comments or send me a message. I definitely want your feedback so that I can use it to include in the next part. Which in the next part, we're going to be digging deeper into Git history and differences. We're going to learn how to jump around in that history to like go back to a previous revision, how to revert a commit, a bunch of interesting little tidbits that we really didn't have time for in this video without this video getting crazy long. So please join me in the next part. I look forward to seeing you then. Bye-bye.